The National Electrical Code, or NEC, mandates arc fault circuit interrupter, or FSI, protection for specific circuits within dwelling units. Specifically, all 120-volt, single-phase, 15 and 20 amp circuits supplying outlets in dwelling units, including bathrooms, must be protected by FSIs. This requirement aims to enhance safety by mitigating the risk of electrical fires. Bathrooms are classified as high-risk areas due to the proximity of water and electrical appliances. The presence of moisture increases the potential for electrical faults, making FSI protection crucial. FSIs are designed to detect and interrupt dangerous electrical arcs, which can occur in damaged wiring, loose connections, or faulty appliances. These arcs generate heat and can ignite surrounding materials, leading to a fire. By promptly interrupting the circuit when an arc is detected, FSIs prevent the arc from escalating into a fire hazard. In a typical residential electrical system, the power enters the home through a service panel, often located in the basement or garage. From the service panel, circuits branch out to various areas of the house, providing power to lights, outlets, and appliances. Each circuit is protected by a circuit breaker, which is designed to trip and shut off the power if an overload or short circuit occurs. FSIs provide an additional layer of protection by detecting arc faults, which may not be detected by conventional circuit breakers. There are two main types of FSIs: branch/feeder FSIs and outlet branch circuit FSIs. Branch/feeder FSIs are installed in the service panel and protect the entire branch circuit. Outlet branch circuit FSIs are installed at the first outlet in the circuit and protect the rest of the circuit downstream. In the case of a bathroom circuit, either type of FSI can be used to meet the code requirements. However, it's often more practical to use an outlet branch circuit FSI, as it can be easily installed in place of a standard outlet. When installing an FSI, it's important to follow the manufacturer's instructions carefully. The FSI should be wired correctly, with the line wires connected to the terminals labeled line and the load wires connected to the terminals labeled load. The FSI also needs to be properly grounded to ensure that it functions correctly. After the FSI is installed, it should be tested to verify that it's working properly. Most FSIs have a test button that can be pressed to simulate an arc fault. When the test button is pressed, the FSI should trip and shut off the power to the circuit. If the FSI doesn't trip when the test button is pressed, it may be defective and should be replaced. In addition to protecting against arc faults, FSIs also provide protection against ground faults. A ground fault occurs when electricity flows from a live wire to ground, which can happen if a wire comes into contact with a metal object or a wet surface. Ground faults can be dangerous as they can cause electric shock. FSIs are designed to detect ground faults and interrupt the circuit, preventing electric shock. The NEC also requires ground fault circuit interrupter, or GFCI, protection for outlets in bathrooms, as well as other wet locations such as kitchens, laundry rooms, and outdoor areas. GFCIs are similar to FSIs in that they detect and interrupt electrical faults. However, GFCIs are specifically designed to protect against ground faults, while FSIs protect against both arc faults and ground faults. The combination of FSI and GFCI protection provides a comprehensive level of safety in bathrooms and other high-risk areas. It's important to note that FSIs and GFCIs are not interchangeable. They serve different purposes and protect against different types of electrical faults. While an FSI can provide ground fault protection, it's not a substitute for GFCI in locations where GFCI protection is required by the NEC. Similarly, a GFCI doesn't provide arc fault protection and can't be used in place of an FSI where arc fault protection is required. The NEC is updated every 3 years, so it's important to stay current with the latest requirements. Electrical contractors should be familiar with the NEC and follow its guidelines to ensure that electrical installations are safe and code compliant. Failure to comply with the NEC can result in fines, penalties, and liability in the event of an electrical fire or injury. In addition to the NEC requirements, some local jurisdictions may have additional electrical codes or regulations. It's important to check with the local authorities to ensure that all applicable codes are followed. Electrical safety is paramount, especially in areas where water and electricity are present. By installing FSIs and GFCIs in accordance with the NEC, electrical contractors can help prevent electrical fires and protect the safety of occupants. When working with electrical systems, it's essential to take precautions to avoid electric shock. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Remember, electricity can be dangerous, and it's always better to be safe than sorry. The NEC is a comprehensive set of guidelines for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is developed and maintained by the National Fire Protection Association, or NFPA, a non-profit organization dedicated to reducing fire hazards. The NEC is widely adopted throughout the United States and is considered the authoritative source for electrical safety standards. Electrical inspectors use the NEC to verify that electrical installations are safe and code compliant. Inspectors typically review the plans for electrical work and conduct on-site inspections to ensure that the work meets the NEC requirements. If an electrical installation fails to meet the code requirements, the inspector will issue a notice of violation, which requires the contractor to correct the deficiencies. Failure to correct the deficiencies can result in fines, penalties, and even the revocation of the contractor's license. The NEC is not a static document. It is constantly evolving to keep pace with new technologies and safety concerns. The NFPA updates the NEC every 3 years to incorporate the latest advancements in electrical safety. The updating process involves input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, and regulators. The proposed changes to the NEC are reviewed by technical committees, which are composed of experts in various areas of electrical safety. The technical committees make recommendations on whether to adopt the proposed changes. The recommendations of the technical committees are then submitted to the NFPA membership for a vote. If the proposed changes are approved by the membership, they are incorporated into the next edition of the NEC. The NEC is a valuable resource for electrical contractors, engineers, and inspectors. It provides a clear and concise set of guidelines for electrical installations. By following the NEC, electrical professionals can ensure that their work is safe and code compliant. The NEC is available for purchase from the NFPA and other sources. It can also be accessed online through the NFPA website. In addition to the NEC, there are other electrical safety standards and guidelines that may be applicable to specific situations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment and components. The Institute of Electrical and Electronics Engineers, or IEE, develops standards for electrical engineering practices. It's important to be familiar with all applicable electrical safety standards and guidelines to ensure that electrical work is performed safely and in accordance with industry best practices. When working with electrical systems, it's always best to err on the side of caution. If you're not sure about something, consult with a qualified electrician or electrical engineer. Don't take risks with electricity, as it can be dangerous and even deadly. By following the NEC and other electrical safety standards, you can help prevent electrical fires and protect the safety of yourself and others. Remember to prioritize safety above all else when working with electrical systems. The 120-volt, single-phase, 15 and 20 amp circuits mentioned in the NEC are common in residential wiring for powering lights, receptacles, and small appliances. Single-phase power refers to a type of alternating current electrical power where the voltage varies in a single cycle. This is in contrast to three-phase power, which uses 3 alternating currents offset from each other to provide a more constant and efficient power supply, commonly used in industrial applications. The 120-volt level is the standard voltage for residential outlets in North America. The 15 and 20 amp ratings indicate the maximum current the circuit is designed to safely carry. Using devices that draw more current than the circuit is rated for can overload the circuit and potentially cause a fire. The NEC specifies that these types of circuits, especially in locations like bathrooms, require a PSI protection because of the increased risk of electrical hazards.